Even normal, nothing was going to happen. But he decided to be outgrown. Too excited. Good evening, good evening, good evening. Good evening, good evening, good evening. Good evening, good evening, good evening. Boys and girls, good evening. Mapwork. I've got 4 sets of papers that I have here. 2024 NSC. I've got the June 2025 Gauteng. I've got the Prep 2025 Gauteng. Then I've got the NSC 2025. So the way I'm going to do this, I'm going to start first. I'll go through all the papers. I'll do the map calculations. Then after map calculations, we do the interpretation. Then we do also the GIS. Yeah, I understand some of you are writing tomorrow, guys. If you feel like you want to rest, please, you can just continue with your study, guys. Please, you can just continue with your studies. We are doing Mapwork. So we have got 4 sets of papers here. We are going to start off first with map calculations. Then after map calculations in all the papers, we move on to map interpretation. Or we can do map calculations, GIS, then we come to interpretation. I think that will be fine. That's how we're going to do it. We are going to do map calculations. I think I will start in 2 minutes. I just want the others to join in. In 2 minutes, we can start. I understand some of you are writing paper 1. We have already exhausted everything that is to do with paper 1. So that's why I'm just helping with the Mapwork, so that because Mapwork is applying both to paper 1 and paper 2. So you are not that lost. If you are here, you're writing tomorrow, you can just stay for some minutes, then continue with your study. But here today we are revising Mapwork. That's what we are doing today. 1 minute for us to start. We are starting at 2 past. We're just giving others a chance to join in. 1 minute. Then we are starting. Just a minute, then we are starting. So we have got 3 set. It's actually 4 set of papers. I've got the 2024 NSC. I have the 2024 NSC. Then I have got this June 2025 for Gauteng. I've got this Prep as well. It was for Gauteng. I also have the 2025. So we are doing Mapwork. Yeah, tomorrow, I think Gauteng, part of Gauteng, you are writing paper 1. It's fine. We are doing Mapwork today. But if you feel like you want to do study your paper 1, please feel free, guys. You can join us some other time. Please don't be distracted on what you have planned to start. Today here we are only doing Mapwork. So if you have some other plans to start your paper 1, please don't be distracted with this. Please go and start. All right, let's start now. It's 2 past. We are starting now. It's 2 past. We are starting now. I just want to take out my paper. All right. So here's what we have. Let's start now. So we have got this. Usually I highlight so that at least you can see. I can emphasize exactly what I want you to know. So here's our map. Our Mapwork section B. So what do we have? We have got this. This is the general information on Bloemfontein. The general information on Bloemfontein. That's what we have, the general information on Bloemfontein. So what we have, Bloemfontein is the capital city of Free State. It is located in central South Africa on the south edge of Highveld. The area is generally flat with isolated hills, although agriculture is the main primary activity. Business mainly thrives Bloemfontein's economy. Due to many businesses, it has attracted more people into the area. This has led to many new developments. So it is very important that you go through your general information, because you might get some of the answers from the general information. What do I mean by that? You can be asked about the province where Bloemfontein is located, which means this is something that is coming from the general information. So it's very important that you go through the general information. So this is the map of Bloemfontein that we are using. This is the map of Bloemfontein that we are using. This is your topographical map, and this is your orthophoto map. This is the map that we are using. Okay, so let's go right away. So the first question now is number 1. That is the first question there. That is our first question. It reads, the topographical orthophoto is a small scale. So when it comes to small and large scale, let me just try to explain. When it comes to large and small scale, this is the technique that I want you to use. What is the scale of the topographical map? The scale of the topographical map is 1:50,000. What is the scale of your orthophoto map? Is 1:10,000. Okay, so the bigger the number, the smaller the scale. The smaller the number, the larger the scale. The bigger the number, the smaller the scale. The smaller the number, the larger the scale. Which means your orthophoto now, what we are implying is your orthophoto. This is your topographical. Topographical. So we are saying the bigger the number, the smaller the scale. The smaller the number, the larger the scale. So from this, which one do you think is large scale and which one do you think is small scale between a topographical and an orthophoto map? We have said that the bigger the number, the smaller the scale. Which one has got a bigger number between the topographical 1:50,000 and the orthophoto 1:10,000? Which one has got the bigger number? The bigger the number, the smaller the scale. Which one has got the bigger number? Which one has got the bigger number? The bigger the number, the smaller the scale. The smaller the number, the larger the scale. So we are saying our topographical map is a small scale map. It shows a larger area and is less detailed. So our topographical map is a small scale map, and our orthophoto map, the smaller the number, the larger the scale. It shows a small area but is more detailed. So that is the difference between your small scale and your large scale map. So a small scale, we have said that the bigger the number, the smaller the scale. A small scale, it shows a bigger area but with less detail. And a larger scale, it shows a small area but with more detail. That's basically what we are talking about. That's basically what we are talking about. So your topographical map is a small scale map. The bigger the number, the smaller the scale. The smaller the number, the larger the scale. That's basically what we are. I don't think you forget it from that. Okay. The bigger the number, the smaller the scale. The smaller the number, the larger the scale. All right. So what is our answer now on 3.1.1? A dash, the topographical photo map has a smaller scale. Which one has got a smaller scale between the two? Which one is a smaller scale? I have said the bigger the number, the smaller the scale. The larger the number, the bigger the number, the smaller the scale. The smaller the number, the larger the scale. So which one between topographical and orthophoto has got a small scale? Which one has got a small scale? Which one has got a small scale? I want you to say something before I can give you the answer. Which one has got a small scale? We have said the bigger the number. Oh, that's correct. So it means our answer here is topographical map. It has got a small scale. That is your topographical map. It has got a small scale. I'm seeing some people who are writing orthophoto. Guys, an orthophoto map is a large scale map. The smaller the number, the larger the scale. Topographical map is a small scale map. The bigger the number, the smaller the scale. Remember, your topographical map, you have got a scale of 1:50,000, and your orthophoto has got a scale of 1:10,000. So the bigger the number, the smaller the scale. which means your topographical is a small scale map and your orthophoto is a large scale map. If you are fine with that, can you give me a thumbs up so that we can move on? So it means the topographical is a small scale map. If you are fine with that, can you give me a thumbs up so that we can move? All right, sharp. So let's move on to 3.1.2. It reads 3.1.2, it reads a small scale shows. What does a small scale show now? A small scale shows, what does a small scale shows? Remember, we have said a small scale, it shows a larger area but with less detail. And a larger scale map, what does it do? It shows a small area but with more detail. So what does a small scale map shows? From the options that are given there, what is the answer? What is the answer from the option given? So we have said it shows a bigger area, which is a larger area. And in terms of the detailedness, is less detail, which means our answer is what? Is D. That's correct. Our answer is D. All right, let's move on to the next one. This one, I want you to pay attention, guys. This one, I want you to pay attention. This is something to do with coordinates. This has something to do with coordinates. So it reads the grid reference of the reservoir at F in block B1 on the topographical map is. So when we are, the first thing is, when you are doing map work, take note, they tell you the map to use. They are saying on the topographical map. So the grid reference of this feature, that is the reservoir, F in, we are going to get it from the topographical map. So let's see what this feature is a reservoir. Can you see here? These are, that is shown here in blue. Can you see? That is the grid reference that we want to find out. Okay, the grid reference for this reservoir in block B1. Okay, so what do we have? The first thing is, I want you to look in your map. If you can just, all right. So what do we have? You have to be able to first identify your latitude and longitude. So can you see this number? Can you see this number? 2901 south. So this is your latitude. 29 degrees 01 south. That is your latitude. So your latitude, it increases going southwards. Why? The number increase going towards the south. So it means the only thing that is going to change on your latitude is the minutes. That is the only thing that is going to change. So 29 degrees 01 minutes south. So let's see, let's add the minutes going downwards until we get to 2906 that we have here. Until we get to 2906. So let's add the minutes. So it means here we have got 0, 2 minutes. We have got 0, 3 minutes. We have got 0, 4 minutes. What else do we have? We have got 0, 5 minutes. So your latitude, they are horizontal. Check here. From where it's starting, 29 degrees 01 south. So this is 29 1 minute south, 29 2 minutes south, 29 3 minutes south, 29 4 minutes south, 29 5 minutes south. Then at the bottom, you've got 2906 south. So these are your lines of latitude. Of course, from north, okay, they are increasing going southwards. Sorry, they are increasing going southwards. So the degree, it remains the same. The only thing that is changing is the minute. So we have got 1, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6. So in all these, we did not write 29, but we can even write 29 degrees 2 minutes south, 29 degrees 2 minutes south, 29 degrees 3 minutes south, until we get to the bottom where we have got our last latitude here, that is 29 degrees 6 minutes. Okay, so that is your latitude in terms of degrees and minutes. Then let's check our longitude now. Our longitude, can you see here at the top, 26 degrees 10 minutes east, which means the number increased going towards the east. So we are going to add the minutes towards the east, which means this is 10, that is 11 here. Okay, let me write them down. 11 minutes, 12 minutes, 13 minutes, 14 minutes. Okay, so we are starting from 10 minutes. then 11 minutes here, then 12 minutes is increasing going towards the east, then 13 minutes, then 14 minutes, then lastly we have got our 26 degrees 15 minutes east. So are we fine with identifying the latitude and longitude? I want to start with that first. Are we fine with identifying the latitude and longitude? Are we fine with that first? Is there anyone struggling with identifying the latitude and the longitude? Are we fine? Okay, so if we are fine, let's continue now. If we are fine, let's continue. So we have been told from our question paper that F is in block B1. Okay, before we even look at the answers, we want to identify the degrees and the minutes first. We will do the seconds. We want to identify the degrees and the minutes first. So what do we have now? We have got this R that we have here, the R that is in block B1. So let's identify first the degrees and the minutes. The degree in terms of latitude is 29. Okay, let's write 29. I'm going to write 29 here, 29 degrees. How about the minutes now? Okay, check here, 29 degrees 1. Okay, then 2. It means anything behind the 2 is still 1. Then from our 2 we go to 3, where we have got our B1. All right, so anything behind the 3 is still 2. It means now our minutes is 2. Why? Because 2 is behind 3. Our reservoir, which is F, is between 2 and 3 minutes. So it's still 2 minutes. Because it's behind 3 minutes, it's between 2 and 3. So our minutes there is 2 minutes. Okay? So we have got 29, 2, 0, 2 minutes. I'm not going to write the seconds. I just want to write also to acknowledge only the latitude. That is your 29 degrees, 2 minutes, because it's found between 2 and 3. That's where our reservoir is in B1. So we have only written the degree. We have written the minutes. Let's look at our longitude now. Our longitude, what we have here, is in B1. So it means it's between 26 degrees 10 minutes east and 11. That's where it is. So it means our feature is between 10 minutes and 11 minutes going towards the east, which means anything behind 11 is still 10. So it means our longitude will be 26 degrees 10 minutes. All right, I did not write the seconds. I'm going to use the elimination method. I did not write the seconds. Okay, so if you look at A, can you see now I've only written what I have on the map. So it means if I look at A is 26 degrees 10 minutes, which is wrong, which means A already is out. I'm taking it out. A is out. I'm taking it out because my latitude is 29, not 26. Okay, let's look at B. What do we have at B? We have got what? 29 degrees 2 minutes is the same, my latitude, but I have not yet calculated my seconds. Let's look at longitude, 26 and 10, but I have not yet calculated my seconds, so it's not yet verified. Okay, then let's look at number C. Number C is out because it's saying what? 2901. So C is also what? Out. C is out. Okay, look at 10. What is D saying? What is D saying? D is saying 26 degrees 10 minutes, which is also out. It's not the latitude. So even before I calculate the seconds, I have already eliminated 3. Can you see how I have eliminated these 3? Can you see how I've eliminated the 3? Can you see how I have eliminated the 3? Guys, can you see how I've eliminated the 3? I have not yet calculated my seconds, but I have just identified the latitude and minutes, the latitude and minutes for both latitude and the longitude. That's how I managed to get my answer very fast. Are we all fine, guys? Is there anyone confused? Is there anyone confused? Anyone confused? All right, we have said we want to find this feature in block B1, that is a reservoir here. So the first thing that we did is we have got answers that are given A, B, C, and D. Okay, A, B, C, and D, that is given there. So what we have done is we have tried to write the latitude in terms of degrees and minutes according to the way it is given on the map. That's what we have started with first. So we haven't done the seconds. Okay. The seconds, we'll calculate them. I'll show you how to calculate the second. We haven't done that, but we have just used the strategy of elimination. We are eliminating the wrong answers. How did we do it? I first explained that how you identify your latitude. Your latitude, can you check here? 29 degrees south. South, that is your latitude, which means your latitude, the number increase going towards the south. That's what it does. Or you want me to repeat the question? The question is saying the grid reference of reservoir F in block B1 on the topographical map is. So these are the answers that are given. So we are looking for the grid reference of the reservoir F in block B1. So this is our block B1 here. This is our block B1 here where we have got this reservoir. So what we have done is, the first thing I did was to help you locate your latitude. This is your latitude here, shown at the corner there, 29 degrees, 1 minute south. So the latitude, the number increased going towards the south because it's in the southern hemisphere. The number increased going towards the south. So that's why we have got 01, then 02, 03, 04, 05. Then at the bottom there, you have got your 29 degrees, 06 minutes south. So your latitude increase going towards the south. That's what it does. Okay? Then how do you identify your longitude? Your longitude, you see here at the top, the line that is going, the vertical line that is going towards the top, 26 degrees, 10 minutes east. So your longitude, it increases going towards the east because it's in the eastern hemisphere. So what it does is the minutes is the only thing that changed. The degree remains the same. So you've got 10, 11, 12, 13, 14. Then here you can see you've got 26 degrees, 15 minutes east. So now that we are able to locate our latitude and longitude, let's go and see where our reservoir in B1 is in terms of degrees and minutes. That's what we have done now. So we have said now our block B1 is here. Our block B1 is here. What is the latitude and minutes? Is 29 degrees, and our minutes is between 2 and 3, which means our reservoir is still in 2, because anything behind 3 minutes is still 2 minutes. So our reservoir is still under 2 minutes. So it means now in terms of latitude, here we have got it is in 29 degrees 2 minutes. We haven't written the seconds, but we have seen that it is under 29 degrees 2 minutes in the southern hemisphere. That's what we have done. We have identified our latitude. Okay. How about in terms of longitude? Can you see where our reservoir is? Is between 26 degrees 10 minutes east and 26 degrees 11 minutes east. So it means it's between 10 and 11. So anything that is behind 11 is still 10. So that's how we have come up with this longitude. That is the 26 degrees 10 minutes east. But we have not yet written our seconds. So let's look from the answers that we have. What do we have in A? A is giving us the latitude as 26 degrees 10 minutes, which is wrong. We don't have that latitude on our map. So we have taken it out. That's why I put a cross here. We have taken it out, which means it's not the correct answer. Second one, 29 degrees is correct. 2 minutes is correct. That's what we have here. That's what we have here. Okay? Let's look at the latitude. We are not considering the second. The latitude, the longitude, 26 degrees, 10 minutes, it's also correct. That's what we have here. That's what we have written down so far. Let's look at number C. We have not yet verified the second. Let's look at C. C is saying 2901 is latitude, which is wrong, which means we are also eliminating it. We are also what? Eliminating. We are taking it out. Is wrong. Then D is saying 26 degrees 10 minutes, which is also wrong. So we are also what? eliminating. So even before we calculate the seconds, our answer is B. Before we calculate the seconds, okay, our answer is B. So how do we find the seconds now? That is the question that I'm going to answer now. How do we find the seconds? So if this is how you find the seconds. So the first thing that you do, you have to know the length of your grid from 2 to 3. Here, from 2 to 3. Can you check here? I'm going to measure from here up to there. Can you see I'm measuring from here up to where it ends here? So it's around 3.7. From here up to there, I will measure the whole grid from 2 seconds to 3 seconds. It's giving me a length of about 3.7 centimeters. So I have got there what is 3.7 centimeters. 3.7 centimeters. So what I'm going to do, I'm going to take 3.7 centimeters there. Okay. So I'm going to measure now from 2 minutes up to where the reservoir is. From 2 minutes up to where the reservoir is. Can you see where the reservoir is? It's somewhere here. It's somewhere here. So let's measure together. You can see it's slightly somewhere around, I would say, this is our reservoir here. Our reservoir is somewhere around 33, 34. Let's use 34. Okay, it's around somewhere around 33, which is 3.3 or 3.4. Let's use 3.3. So I'm now going to say the shortest height, which means I'm measuring now. Let me just draw. Okay, 0, 2 minutes, 0, 3 minutes. So we are saying this is our latitude. Okay, can you look at this? 0.2 minutes to 0.3 minutes. So we are saying the length from here up to there, we have got something like 3.7 centimeters. That's what we have. That's how long this grid is from here up to there. So if I'm going to measure from 2 minutes up to where the reservoir is, I've got something like 3.4 centimeters. That's what I have. So I want to convert this distance in centimeters to seconds. Okay, so how do I go about it? I'll take the shortest distance, which is 3.4 centimeters over the longest distance, 3.7 centimeters. Then I'll multiply by 60 seconds. That's what I'll do. I'll take the shortest distance, 3.4 centimeters over 3.7 centimeters. Then I'll multiply by 60 seconds. That's what I do. Are we together? 3.4 centimeters, which is the shortest, multiplied by over 3.7, which is the longest, multiplied by 60 seconds. The 3.4, I got it when I measure from the 2 seconds up to where the feature is. That's where I got the 3.4 centimeters. Then the length of the whole grid from 2 minutes to 3 minutes is 3.7. So that's where I got the 3.4 centimeters divided by 3.7 centimeters multiplied by 60 seconds. That's where I got it. Are you following? Give me a thumbs up if you're following. Let's calculate now. Let's do our calculation. So what I'm going to do now, I'm going to take my 3.4 over 3.7. Can you see? 3.4 over 3.7. Then I'm going to multiply it by 60 seconds. Okay. I'm going to multiply it by 60 seconds. What is my answer? Can you see my 55? Check my 55 seconds, guys. Ha 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 ha. Check. What do we have here? Can you see the 55 seconds here? Can you see the 55 seconds here? 29 degrees, 2 minutes, 55 seconds. That's where it's coming from. Can you see? I've said the shortest distance, which is 3.4 over 3.7 multiplied by 60 seconds. Then I got 3.4 centimeters over 3.7 centimeters multiplied by 60 seconds. Then I got the 55 seconds. This is what we have on our answer, which is B. Are you following? Are you following, guys? Are you following? So 29 degrees, 2 minutes, 55 seconds south. Okay, Are we together? Are we together? All right, 29 degrees, 2 minutes, 55 seconds south. Are we together? Okay, sharp. Let's find out now our longitude. Let's find out about our longitude now. So what we are going to do, we are going to apply the same concept, okay? We are going to find out now from, I'll do it like this, from 26 degrees, 10 minutes to 11 minutes. So I'm now going to measure the length from here, from 10 minutes, 26, 10 minutes to 11 minutes. That's what I'm going to measure. So I want to know the length from here up to there now. That's what I want to know. Let me measure now. Okay. So if we measure now, we want to find out, going towards the east, what would be our, we are going to get something like 3.3, if I'm not mistaken. Something like 3.3. Something like 3.3 centimeters or 3.2, somewhere there. You're getting something like 3.2. Can you try to measure if you have got a map? I think I'm getting 3.3. That's what I'm getting. Check nicely the wall, read, of course. I'm getting 3.3. So I have now, from here, 10 minutes to 11, I've got something like 3.3 centimeters. Okay, so now let's measure from 10 minutes up to where the reservoir is. 10 minutes up to where the reservoir is. We are going to get something like, can you check here? It's slightly above, it's about 0.5, 0.6 centimeters. I've got something like 0.6 centimeters, 0.6 centimeters. Okay, so we are saying now there is 0.6 centimeters up to where the reservoir is. Okay, we have got something like this. So we can even use 0.7, it's fine. So we are now saying 0.7 centimeters over 3.3 centimeters multiplied by 60 seconds. That's what we are doing. 0.7 centimeters over 3.3 multiplied by 60 seconds. Let's see what answer we're going to get there. All right, 0.7 over 3.3 multiplied by 60 seconds. That's what we are doing. 0.7 over 3.3 multiplied by 60 seconds. So what is our answer? Okay, let's find out. Can you see? Remember, we've said it's 0.6, 0.5. Okay, we have got there 12.7, assuming that it ranges from, let's say, 0.5, 0.6, somewhere there. So we have got our 12 here. Can you see our 12 seconds here that we have here on the answer? Can you see our 12 seconds on B? So that's how you can get the answer B. If it's fine, please just let me know. Remember, we are ranging. Okay, we can round it off, but remember, we are ranging from 1.6 to 1.7, so it's fine. We can even round it up, but you can see how we get a number that is close to 12. So that is it. Can we move on to the next? Give me a thumbs up so that we can move on to 3.1.4. Thumbs up. Let's move on to 3.1.4. 3.1.4. I think I've got a majority thumbs up there. All right. So 3.1.4, it reads 3.1.4. It reads what we have on 3.1.4 now is saying, all right, sorry, I just want to take it closer. 3.1.4, it says, determine the true bearing of spot height. You are referred to the orthophoto. First thing, the map that we are using is an orthophoto map. Let's take note. We are using an orthophoto map. That's why they are saying refer to the orthophoto. So we are using the orthophoto map. Take note. All right. Take note. We are using what? The orthophoto map. Determine the true bearing. The true bearing of spot height 143186 in block A3 from spot height 142787 in block B4. So there are two things that should guide you. Number one, where is your from and to? These two words are very important. From and to. From and to. From and to. Those two words are very important. So we are saying we are using our topographical map. So which one is our from? The from spot height 1427. 1427. This is our from part. Okay, 1427. This is our from 1427. And our to is 1431, which means we are measuring from here. So the first thing that we do is we draw a perpendicular line that passes through the from part, which is this line that I'm showing with a ruler. This is the line. We draw this line. Can you see? We draw this line. Can you see? We do this so that we can be able to identify our true north, because we measure our true bearing from the true north. So we draw a line that passes through the from, which is this spot height 1427. Then next, we identify our true north, TN. That's where we measure from. Then the third stage, we connect the 2 points, spot height 147, from spot height 147 to spot height 1431. So we draw a line from the spot height that we are measuring our true bearing from to the one that is connecting to it, that is 1431. So it means now we are measuring our true bearing from here in a clockwise direction from the true north, which means we are going to measure this part from here up to there. That's what we are going to do. From here up to there. That's what we are going to do. Do we all understand? Do we all understand? Give me a thumbs up if you understand. Give me a thumbs up. Give me a thumbs up if you understand. Give me a thumbs up if you understand. Give me a thumbs up if you understand. Okay, so we are measuring our true bearing from the true north. So this is how we do it from the true north. I think most of you understand. Okay. Come on, guys. Can you please start? I don't understand. All right, I'm going to start again. It's fine. I'm going to start again. The question says, determine the true bearing of spot height 1431 at 6 in block A3 from spot height 1427 at A in block B4. In block B4. We are doing 3.1.4. That's what we are doing. 3.1.4. Okay. Are we together? All right. Are we following with the question? So we are saying determine the true bearing of spot height from 1431 at 6 in block A3 from spot height. So I have said that when you are calculating your true bearing, you have to make sure that you identify where you are measuring your true bearing from. So that's why I've said these two words are important, from and to. They are very important. So what do we do next now? We look on our map. We go to our map here. It said the orthophoto. So this is the from. Here, this is the from. This is the from here. We are measuring from this spot height at 7. This spot height, which is 1427. So the first thing that you do is you draw a line, a perpendicular line that passes through 1427. This is your line here that I've drawn with a pencil. I know it's not that visible. So the reason why I draw this line, I want to identify my true north, where I'm going to measure my true bearing from. So I have drawn the line that passes through 1427. I have identified my true north, TN. My true north is where I measure my true bearing from. That's number one. Number two, I have connected the two spot heights. Okay? That is the from 1427 and the to 1431. So I've drawn a line that connects these two spot heights. I'm going now to measure my true bearing in a clockwise direction from the true north, which means I measure here. Can you see here? I'm going to measure this, the angle that I'm going to measure in degrees. This is the angle that I'm going to measure here in a clockwise. From the true north, I'm going to measure this. Are we together? Are we together? Are we together? All right, sharp. So I'll take my protractor now. I'll take my protractor. Here is my protractor. Okay. I make sure that I measure from 0. Okay. All right. So I've got my protractor here. I'm going to place it at the from spot height. Can you see here? I've placed it here. Of course, I've placed it here. Can you see? First, I've got a straight line here, which gives me about 180. Which gives me about 180 from 0 up to 180 degrees. So I'll say 180 degrees, 180 degrees. Remember, I have only measured the straight line. I've only measured the straight line. That's what they've given me, 180 degrees. I want to measure the remaining angle here. I want to measure the remaining angle on the other side. So I'll take my protractor. I do the same thing. I place it here. I place it here. Then can you see? I've got something like, can you see where my 1431 is? Is somewhere here. Can you see where this line is? Somewhere around 137. 130, 135. You can see somewhere around 137. I would say somewhere around 137. So I'm going to add that 137 to the 180 on a straight line. That's what I'm going to do. I'm measuring from here, from 0, going until I go where this line is. That is 137. So I'm going to say plus 137 degrees. So I have got 180 plus 137. This is what I have. I'm going to add the 2 to find my true bearing. What is the answer there? 317. That is my true bearing. That is my true bearing. So I've got what? 317. Don't forget to write degrees. That is 317 degrees. Are we together? Are we together, boys and girls? Thumbs up if you're fine. Thumbs up if you're fine so that we can move on to the next. Thumbs up if you're fine. Sharp, 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 sharp. I can see. All right, I can see. Let's go to the next one. Refer to the topographic map. Refer to the topographic map. So it means now the next question, we are using a topographic map. 3.1.5. 3.1.5, we are using a topographic map. That's what we are using now. That's the map we are using. A what? A topographic map. What is it saying now? Calculate the average gradient. Calculate the average gradient from the spot height 1358 at G in block A3 to the trigonometrical station 96 in H in block C4. So we are now calculating our gradient. That's what we are doing. So we have been given a directive that we are calculating from spot height 1358 at G in block A3 and trigonometrical station 96 at H in block C4. So let's write our two heights, okay? From the topographical map, we have said G. Where is our G? There is our G here. Can you see? 1358. This is supposed to be in meters because it shows height on a map. So that is 1358. So we have said 1358. I'll just say meters. Let's identify those two heights. Then the other one is saying trigonometrical station 96 at H in block C4. At H in block C4. So this is what we have here. At H. So we have got something like this. 96. Then we have got 145.6. This is what we have. Okay. So we have got here at H, we have got 96 is the beacon number. It's not the height. The 96 that we have here is the beacon number. The height is at the bottom here. At the bottom. That's where we have got the height here at the bottom, which is 1455.6. That is our height. This is our trig beacon. Beacon number 96. The height is at the bottom of this triangle, 14556. So it's like this. Can you look there? It's like this. We have got this is the beacon number. This one shows what? The height. Can you see? 96 is the beacon number. This is the what? The height. So our height is 1455.6 meters. So we have got 1455.6 what? Meters. So most of you usually use the beacon number instead of the height. Okay. So we have got the 1358 meters here. 1358. Let me show you at G. 1358. Then let's go where we have got our H here. We have got beacon number 96 and height 1455.6, which is like this. All right. Are you following? I want to find out if you are following first. So these are the two given heights that we have. These are the two given heights that we have. That is spot height 1358 meters spot height. Then the trig beacon, the beacon number is 96. This is the height. So on a trig beacon, you have got two numbers. This is the beacon number, and this is what? The height. Okay, sharp. Then use the following information. The distance between the spot height is 7.8. So we are given the map distance. This is the map distance that we are given. So it means we still have to calculate the distance. That's what we have to do. So what do we have now? I want to get my paper so that I can calculate. Okay. So what is the formula now for our gradient? What is the formula for our gradient? Our gradient now, let me write it. Then our gradient, you can see here, vertical interval over horizontal equivalent. That is our formula. Let's write the formula. Gradient is equal to vertical interval over horizontal equivalent. So this is how we do it. Vertical interval over horizontal equivalent. Okay. Vertical interval over horizontal equivalent. That's how we calculate our gradient, which is what we have here. Vertical interval over the horizontal equivalent. So from the height that we are given, we have got two heights. Okay. Which is what? The 1455.6 meters minus the 1358 meters. These are the two given heights. These are the two given heights that we have, which gives us our vertical interval. These are the two given heights that we have, which gives us our vertical interval. Okay. The difference in height, that's basically what we are talking about. Okay. So our vertical interval, we're going to get it by subtracting the highest height minus the lowest height. That's how we're going to say. That's how we're going to do it, which is what we have here. Our trig beacon is 1455.6 height. Then our spot height is 1358 meters. So the highest height is 1455.6. That's why we have written it here as 1455.6 meters minus 1358 meters. That is our VA. So for our horizontal equivalent, is the same way we calculate distance. Here we are given the map distance. So our distance is equal to map distance multiplied by scale. That's how we calculate it. So we are going to use the same formula. So what do we have as our map distance? We are given here is 7.8. So we don't have to measure it. It's already given. So we are going to say 7.8 centimeters. The scale that we are using is the scale of the topographical map. And remember, this has to be in meters. The scale of the topographical map, and we have to calculate in meters. Okay, so how are we going to do it? What is our scale in as far as the topographical map is concerned? is 1 is to 50,000 centimeters. So we are going to convert this into meters, which means we divide 50,000 divided by 100, then we are going to get 500. Okay, we are going to get what? 500. We have converted the scale of topographical map from centimeters to meters. We did this by dividing the 50,000 by 100. That's how we got the 500 meters. So it means now we are going to multiply our 7.8 multiplied by 500 what? Meters. That's what we are going to do. So if we subtract now our 1455.6 1455.6 minus 1358. What do we have? 1455.6 minus 1358. What is our answer? All right, can you see our answer there? 97.6, which means we are going to have our VI is what? 97.6 what? Meters over. Do you understand this stage? Thumbs up if you understand how we got the VI. Can you give me a thumbs up if you understand how we got the VI? 1455.6 minus 1358 meters. Thumbs up if you understand how we got this. All right, let's calculate the horizontal equivalent now, or the horizontal distance. We are now going to say 7.8 multiplied by 500. This is how we get our horizontal equivalent. That is 7.8 multiplied by 500. Okay, let's see what we are going to get. We are going to get something like 3,900. We are going to get what? 3,900. So we are going to say divided by 3,900 meters. Okay, so we don't leave it like this. We are going to divide both by the VI, which means here we divide by VI, okay, which is 97.6 meters. We also divide this by VI, which is 97.6 meters. Do you understand this stage? Do you understand this stage now? Where we are. We have got this. We are going to divide both by the VI. So that's how why we are going to say 97.6 divided by 97.6 and 3,900 divided by 97.6. Do you understand this stage now? We divide both by the VI. That is our 97.6. Because this is written as a ratio. So we divide both by the VI. 97.6 divided by 97.6. 3,900 we divide also by 97.6. Are we together? Guys, where are you getting lost? These are simple things, guys. These are simple things. Where are you getting lost? These are simple things. The 7.8 is the map distance. That's why it's given on the paper. Here, 7.8 is given on the paper there. They've already given us the map distance. So we just take the map distance and we multiply it by the scale, which is 500. Are you following? Sharp. I can see the thumbs up. So what are we going to get? 97.6 divided by 19.7.6. We are going to get 1 here. Then 3.9 divided by 97.6. What are we going to get? Okay. Are we okay? That is 3.9 divided by 97.6. All right. Then what are we going to get? Can you see there? We are going to get 39.95. I'm just going to 39.95. I'm going to round it off to 39.96. Okay. So we are going to get something like 39.9. I'm rounding it off. I'm just going to write 39.96. I'm just rounding it off. 39.96. Okay. So it means now we don't leave it like this. You have to write it as a ratio. So your answer is going to be 1 is to 39.9. This is going to be your answer. 1 is to 39.96. That is your answer. You write it as a ratio. So that's how you calculate your gradient. Any problems? That's how you calculate your gradient. Any problems? Is it clear? How do we interpret gradient? That's what we want to talk about now. If it's less than 10, it's what? Is steep. If it's between 10 to 15, it's moderate. If it's more than 15, it's gentle. That's how you interpret your gradient. We are looking at this number. Okay, we are looking at this number. How did you get number one? Come on, guys. 97. We divided by the VI. 97.6 divided by 97.6. That's how we got the 1. Then our 3,900 we divided as well by the VI. That's how we got also 39.96. Okay, so this is how you interpret your gradient. So if it's less than 10, it's steep. If it's between 10 to 15, it's moderate. If it's more than 15, it's gentle. So in this instance, it means our gradient is what? It is gentle. That's what it means. That's what it means. We are now interpreting. Are we together? Are we together, guys? Are we together? All right, sharp. So let's move on to the next question. Are we fine with this part? It's now saying, is the gradient in answer to question 3.15 steep or gentle? Is it steep or gentle? Remember, we said that this is the interpretation. Less than 10 steep, 10 to 15 moderate, more than 15 is what? Is gentle. This is more than 15 is 39. It means it's gentle. Okay. Why would this gradient in question 3.1.6 be an advantage to road construction? Why would be an advantage to road construction? It's gentle. Why would be an advantage to road construction? It's easier to build, cheaper to build, no need for tunnels. That's what you can talk about. So it's very easier to build, cheaper to build. There's no need for tunnels. Okay, that's basically, I'm talking about 3.1.7. Why would this gradient be an advantage for road construction? It's cheaper and easier to build. That is the answer there. All right, so I'm moving on to the next question. Next question paper, still map calculation. Can I move on to the next one? Can I move on to the next one? Map calculations. I'm moving on to the next one now. Yes. Okay. Next paper, map calculations first. What do we have? We are using this now. All right. This is the Gauteng June 2025. Let's go to our map. All right. Let's start with the background information. Background information of Potchefstroom. That's what we have. This is the map that we are using. Let me read the background information. Potchefstroom is an academic city in Northwest Province of South Africa. It hosts the Potchefstroom campus in Northwest University. Potchefstroom is on the Mooi River, approximately 120 kilometers west-southwest of Johannesburg and 45 kilometers east-northeast of Klerksdorp. The city has very few industries and is known for its clean air and low crime rate. It is an important industrial, service and agricultural growth point of the Northwest Province. Industries in Potchefstroom include steel, food and chemical processing. The chicken industry is of key importance. So it is very important that you also read the background information. It's very important that you read the background information because you can get some of the information that can help you to answer the question. Let's move on to the first question. Okay. The first question reads, the contour interval of the topographic map. What is the correct answer there? This is your topographical map. This is your contour interval here. On the map. It's there on the map. Can you see here? It's there on the map. It's there on the map. That's your contour interval. Let me just fix something. Is there on the map. Okay. So that is what? That is 20. That is what? That is 20. Okay, that 20 is your answer there, is 20. Okay, let me just fix this because, okay, your answer there is what? Is 20. I'm just trying to fix my camera here. Okay, so the answer there is 20. I've shown you here, guys. This is the contour interval of the topographical map. Contour interval 20 meters. So your answer there is what? Is D, isn't it? Your answer here on the map at the bottom. Contour interval 20 meters. This is your topographical map. So your answer there is what? Your answer is D. That is your answer. Are we together? Sharp. Let's move on. The length of the bridge in B5. The length of the bridge in B5. So this is the bridge here. Can you see? This is the bridge here. The bridge in B5 is this one. Can you see? So let's measure it. Let's measure the bridge. Our bridge. Okay. We have something like 0.3. We have something like 0.3 as in map distance. So the length, you can calculate the same way you calculate your distance, which is your map distance multiplied by scale. That's how we are going to calculate the length. So our length that we have here, map is equal to 0.3 centimeters. We are going, since this is in meters, what is the scale of our topographical map? Is 1:50,000 centimeters. We divide by 100, get meters, so we are going to multiply by 500 meters. Do you understand this stage? Do you understand this stage? I have got, when I measured the length of the bridge here, I got 0.3. I got 0.3. I got 0.3 here, 0.3 centimeters. This is the bridge here. I got something like 0.3 centimeters. So I'm multiplying that by 500 meters. Okay, so if you say 0.3 multiplied by 500, what is your answer? It's 150 meters. So it means your answer there is what? Is C. Do we all understand? Do you all understand? Thumbs up if you understand. Thumbs up if you understand. Sharp. Let's move on to 3.1.3. It reads, the true bearing from the benchmark in. So take note again, this word is very important. From. The true bearing from the benchmark. Okay, I'll show you what a benchmark is. From the benchmark, this is the landform. In block A2, there are two words that I want you to take note of. From and to. So this, you measure from. Okay, so from and to. Trigonometrical beacon 174F in block B1. In block B1. So you take note of two words, from and to. So let's check now on our map. We are using a topographical map. True bearing from benchmark in A2. A2, where is our A2? A2. All right, A2 benchmark. This is a benchmark. It's a height marking that has got an arrow that is pointing towards the road. That is your benchmark, which means is this 1365.8, and this arrow is pointing towards the road. So this is your benchmark. Your benchmark, like this is a road, okay? Then we have got 1375.3 with an arrow that is pointing towards the road. This is what a benchmark look like. This is what a benchmark look like. This is your benchmark. It is a road. You have got the height, then you have got an arrow that is pointing towards the road. That is what we call a benchmark. So we have got it here. We have got it where? We have got it here in B2. So this is your 1365.8. The arrow is this one that is pointing towards the road. Do we all understand? Do we all understand before we can move on to find out our 2? Are we together? So this is where we are measuring from. Thumbs up if you understand. This is where we are measuring from. Okay, so we are measuring from this benchmark to where? To the trig beacon 174 at F in block B1. So B1 at F, this is where our F is here. So it means the first thing, let's find out our from. Our from is here. Let's draw a line, a perpendicular line. This is our line that we have drawn. This is the line that we have drawn here. Can you see? I've drawn a line. Why am I doing this? I want to identify my true north. The true north is where I measure from. I measure from here. Okay, I measure from the true north. So I drew a line that passes through the benchmark. I have identified my true north. Next thing, I'm now connecting my trig beacon, the trig beacon to the benchmark. I drawn a line here that connects now this benchmark to this trig beacon. That's what I've done. So I'm going to measure now from here towards there. Okay, this is what I'm going to do. I'm going to use my protractor to measure from here up to there. That's what I'm going to do. Can you see? Are we all fine with this? Are we fine with this? That's what I'm going to do. I'm going to measure in a clockwise from the true north, which means from here up to there. That's what I'm going to do. Okay, from here up to there. So how am I going to go about it? I'm going to take my protractor now. Let me check my protractor. Where is my protractor? All right. There is my protractor. There is my protractor. I'm measuring from the true north. I'm going to place my protractor here where my benchmark is. So you can see I have 180 because I'm measuring from 0 up to 180 here, straight line. So I'll have 180 degrees plus. Remember, I have measured only this straight line. That's what has given me 180. I want to measure this remaining, this one. I want to add this angle, the remaining angle, this one. That's what I want to add. So 180 is a straight line. I'm going to add this now. I'll take my protractor. I'll put it like this. Then I'm gonna go to my from part, making sure that it's aligned. So you can see, let me try to make this line longer. Okay, so that at least we get the correct thing. All right, so this is what we have. I've gone to my, okay. Can you see where it is now? Can you see? It's somewhere around 25 degrees, 25, 26, that's where it is. Somewhere around 25, 26 degrees. Let's use 25. So I'm going to say 180 plus 25 degrees. Do you understand this? 180 plus 25. Can you see where I got my 25? So if I add, can you give me a thumbs up if you understand? Plus 25. Thumbs up if you understand. Okay. So I'm going to get this now. 180 plus 25, I'll get 205. That is going to be my true bearing, which is what? 205 degrees. That is my true bearing. That is my true bearing. That is my true bearing. 205. That's my true bearing. True bearing. That's my true bearing. That is my true bearing, guys. That is 205. Remember, let me just do it for the last time. Let me do it for the last time. We have 2 points. We have got the benchmark here. This is the from part, the benchmark. Okay. This is the benchmark, the from part. So we drew a line that passed through the benchmark to identify our true north here. Our true north where we measure from. Then we connected the 2 points. That is your benchmark and your trig beacon here. That's why you see this line that goes down here. So we are measuring the angle now from the true north in a clockwise direction from here up until there. So the straight line here is what you've given us the 180 degrees. The 180 degrees. That's where we got the 180 degrees from the straight line. How? Because when you take your protractor, you place it like this. Okay. The straight line gives you 180 from 0 up to 180 degrees. That's where we got this 180 degrees. So the remaining angle now to get our true bearing is this now. This acute angle here is what we should add to get our remaining, to get our true bearing. So we also take our protractor, then we put it like this. We are measuring from here, from 0, going up until here. You can see it's between 20 and 30, which is about 25. That's how we got it. So 180 plus 25, it gives us 205 degrees. That is our true bearing. So our true bearing would be what? 205 degrees. That's our true bearing. Are we together? Thumbs up if you understand so that we can move on. Thumbs up, thumbs up, thumbs up. Okay, I see that people understand now. Let's move on to the next one. It reads the direction from the benchmark, the direction from the benchmark to the trig beacon in 5. Okay, the same way that we were calculating. What is the direction of the trig beacon from the benchmark? What is the direction? What is the direction? The same way we're calculating. What is the direction of the trig beacon from the benchmark? What is the direction? What is the direction? It's southwest. Remember, there is your north, your south, your west, and your east. There is your north, south, west, and east. So it's between south and west, which is your southwest. That is the direction. Okay. Thumbs up if you understand. Thumbs up. So we are done with that. We are done with that. Let's move on to the next one. Calculate. If you are fine with it, just give me a thumbs up so that we can move on to 3.4. 3.1.4. 3.1.4. Okay, sharp. 3.1.4. Calculate the area of the swimming pool. Calculate the area of the swimming pool at 5 on the orthophoto map. So we are using the orthophoto now to calculate the area. We are using the orthophoto. So I want us to do something, guys. In meters. It has to be in meters. So let's do something. Number 1, what is the scale of our orthophoto? Is 1:10,000, isn't it? This is in centimeters. Okay? Let's change it into meters because we have to calculate our area in meters. We have to calculate our area in meters. This is the scale of our orthophoto because we are using an orthophoto map. So our scale is 1:10,000, which is what we have here. 1:10,000. So let's change this into meters. We will have 1 centimeter to 100 what? Meters. Okay. So the question is saying the length of the pool is 1 centimeter on the orthophoto. So where is our pool? Our pool is here. This is pool 5 here. So they are saying the longest side here is what? 1 centimeter, which means we have to measure only our breadth. That's what we have to measure. So how do we calculate our area? Our area is equal to length multiplied by breadth. That's how we do it. But remember, you do not only calculate it like this. You have to make sure that you calculate your length times your scale times your breadth times your scale. That's how you do it, which means the length is multiplied by the scale. The breadth is also multiplied by the scale. So what do we have? From this question, we are given the length already, which is 1 centimeter. The length of the pool is 1 centimeter. There's no need for us to measure the length because it's already given. The length of the pool is 1 centimeter. So we are going to say 1 centimeter multiplied by, remember our answer has to be in meters, which means we are going to multiply it by 100. Then we do like this. Then the only thing that we have to measure now is the breadth, okay? Which means we have already been told that from here up to there is 1 centimeter. So we are going to measure now the shortest distance, which is our breadth now. Can we do it together? We are going to get something like 0.6. We are going to get something like 0.6 centimeters. That's what we are going to get. We are going to get something like 0.6 centimeters, which means now our breadth is what? 0.6 centimeters multiplied by 100 meters. Are we together here? Thumbs up if we are together. Thumbs up, thumbs up. Are we together? Someone is saying I should put an X. It's the same thing, guys, even without. It shows multiply. This bracket shows that I'm multiplying. This bracket shows that I'm multiplying. I can either put it or just leave it like that. It's the same thing. Okay. So 1 times 1 centimeter multiplied by 100, we are going to get what? Is equal to 100 what? Meters. Okay. Then if we multiply our 0.6 multiplied by 100, 0.6 multiplied by 100, we are going to get what? 60 meters multiplied by 60 meters. Okay. So the next thing that we are going to do is we are going to multiply our 100 multiplied by 60. What is going to be our answer? 6,000. Okay. 6,000 square meters. That will be our answer, 6,000 square meters. Remember, the area is always squared. The area is always squared. So it's 6,000 square meters. If you just write 6,000, it's wrong. On your calculation as well, take note what I've done here. My 1 centimeter has got a unit. 1 centimeter. If you just say 1 times 100, it's wrong. So it's supposed to be 1 centimeter multiplied by, the unit of measurements are very important at every stage. So 1 centimeter multiplied by 100 meters. If you just say 1 by 100, it's wrong. Same applies, 0.6 centimeter multiplied by 100 meters. So make sure that at every stage you include the unit of measurement. That's how some of you lose marks. Then here I've got my length now, which is 100 meters multiplied by 60 meters. Then lastly, I've got my 6,000. If you just write 6,000, it's wrong. You have to write square meters. That's how you're supposed to do it. So take note, when you're doing calculation, make sure that you include the unit of measurement. Make sure that you always include the unit of measurement. Are we together? Are we together? If it's clear, star. If it's clear, just give me a thumbs up. Give me a thumbs up if it's clear. If it's clear, give me a thumbs up. Can we move on to the next one? Let's move on to the next one. Okay, so we have done that. Okay, so the next question now says, the swimming pool on the orthophoto map appears smaller, bigger than the topographical map due to the difference in scale. Does it appear bigger or smaller? The swimming pool on the orthophoto map. Does it appear bigger or smaller? Does it appear bigger or smaller? 3.1.5. The swimming pool, it appears bigger. Why are you saying bigger? It's correct, but why are you saying bigger? Because what? An orthophoto is a what? It appears bigger. Why are we saying bigger? The correct answer is bigger, guys, not smaller. It appears bigger. Why are we saying bigger? Because an orthophoto is a large scale map. The orthophoto is a large scale map. Exactly, 5 times larger. Okay, the orthophoto is a large scale map. That is the reason. The orthophoto is a large scale map. So it appears bigger. It appears what? Bigger. This one appears bigger because our orthophoto is a large scale map. Thank you. Can we move to the next? Okay, sharp. 3.1.6. 3.1.6. Give the latitude of the symmetry at G in block B1 in the longitude, if the longitude is, all right. So we have got this information that is given. we want to calculate or to find out the latitude, we are given the longitude. They are saying on this topographical map, give the latitude of the symmetry at G in B1. G in B1, there is where our symmetry is. Can you see here? It's here, our symmetry. So they are saying that we should give the latitude of this symmetry. That's what they are saying. We should give the latitude of this symmetry. If the longitude is 23, 27, 03, 40 seconds. So it means our latitude has to be in degrees, minutes, and seconds. Okay, so let's go back again. Our longitude here is 26 degrees, 39 minutes south. That is our longitude. 26 degrees, 39 minutes south. That is our longitude. So our longitude increased the number going towards the south, which means the degree remains the same. The only thing that changed is the second, which means here we have got 40 seconds, 41 seconds, 42 seconds, 43 seconds. Then we have got 44 at the bottom. That's why we have got 44 here, because it increased going towards the south. The degree remains the same. So we have got 39, 40, 41, 42, 43. At the bottom, we have got what? 26 degrees, 44 minutes south. Are we together? Are we together? Are we together? Sharp. Then let's, we are only calculating the latitude. So we are not going to worry about the longitude. The longitude is here, 27 degrees 03, which means it increased going towards the east. The only thing that is changing is the minutes. So it means we have 0, 4, 0, 5, 0, 6, 0, 7. And here we have got 0, 8. Okay. So our longitude, it increased going towards the east. Only the minutes are changing. All right, so let's do our latitude now. So the first thing is, let's find out the degree. Okay, where is our symmetry? It's here. So it means our degree is still what? Is 26. So we are going to write 26 degree. The degree is the same for all this latitude. The only thing that is going to change is the minutes. So the degree is the same. So it's 26 degrees. Let's check where our symmetry is. It's between 40 and 41. 40 minutes and 41, which means anything behind 41 is still 40. So our minutes is 40. Our minutes is what? 40. So we have got 40 minutes. We don't have the second, then south. So how do we find out the seconds now? Remember what we did, guys. We measured, okay, from 40 to 41. All right, 40 to 41. So I'm going to demonstrate now. From 40 to 41, we want to measure the length from 40 to 41. Did you still remember what we did? We got 3.7. Do you remember last time when we measured? We got 3.7. So the same thing, that's what we are going to do. From 40 to 41, we got something like 3.7, okay, which is, here we have got what? 3.7 centimeters. From 40 to 41, that is the length of that grid from 40 to 41 where our symmetry is. Can you see? We are measuring from here up to there. We have got 3.7 centimeters. That's number one. We want to know the longest side from our 40 minutes to 41. We have got 3.7. So now let's measure from 40 to where the symmetry is. Let's measure from 40 to where the symmetry is. We are going to use the center of the symmetry, okay? Which means we are measuring from the top. Where is our symmetry? Our symmetry is here. This is where our symmetry is. Our symmetry is here, here. This is the symmetry. All right, let's measure now. Okay, let's use more or less, okay? Can you check our symmetry? Check our symmetry. Check our symmetry. Can you check our symmetry here? From here up to there. Let's deal maybe with the more or less the center. We have got something like, I'm going to use the center. Something like, you can use 14 or 1.4. It's slightly above 10, okay, about 1.4, 1.5. All right, let's use 1.4, 1.5, 1.4. So we are saying the symmetry is here, which is about 1.4 centimeters. That's where our symmetry is. So we are going to say the shortest distance, which is 1.4 centimeters over 3.7 centimeters multiplied by 60 seconds. Are you following here? 1.4 centimeters over 3.7. Thumbs up if you are following. Thumbs up if you are following. 1.4 over 3.7 multiplied by 60. Thumbs up. Okay, so we have got this 1.4 over 3.7, which means from 40 minutes to where our symmetry is over the length of the whole grid, which is 3.7 multiplied by 60. Multiplied by 60. What do we have now? Our answer in seconds will be 22.7. Let's round it off. We have got 22.7. We can say 23 seconds. So our latitude is going to be 26 degrees, 40 minutes, 23 seconds south. That is going to be our latitude. 26 degrees, 40 minutes, 23 seconds south. That is going to be our latitude. We are converting those centimeters to minutes, to seconds. So we say the shortest over the longest multiplied by 60 seconds. That's how we do it. So it's going to be 26 degrees, 40 minutes, 23 seconds south. Thumbs up if it's fine. Thumbs up if it's fine. Thumbs up if it's fine. Guys, this is the second time to do this. Thumbs up if it's fine. All right. We have said, guys, we want to find out. Okay, we want to find out. We have already been given the longitude here. We have already been given the longitude here. So we want to find out the latitude of this symmetry here. So what did we do? We measured the length. Okay, we first find out the degrees and the minutes as what is given on the map. So we have got the degree as 26. Then our minutes, our symmetry is between 40 minutes and 41. So that means it's still behind 41. That makes it 40. So our degree is 26. Our minutes is 40 minutes. Okay. So now we want to find out the seconds. How do we do it now? We measure the length from our 40 minutes to 41, which means from there up to there, even if you get 3.6, you get more or less the same answer. 40 to 41, we have measured with a ruler, and we got 3.7 centimeters. That's what we got now. Then we measured from 40 minutes to where our symmetry is, which means from there with a ruler, from there up to where our symmetry is. That's what we did now in centimeters. Then we got something like 1.4 up to where this symmetry is. We just use the center, about 1.4. So we have taken the shortest distance, which is 1.4, over the distance of the whole grid, which is 3.7, multiplied by 60 seconds, because we are converting these minutes into seconds. That's what we did. We are converting these centimeters into what? The length that we have in centimeters into seconds. That's what we did. That's how we got the 23, which is 1.4 centimeters over 3.7 centimeters multiplied by 60 seconds. That's how we got the 23. That's how we got this 1.4 over 3.7 multiplied by 60. That's how we got the 22.7. We just round it off. Is it clear now? It's clear, right? Thumbs up if it's clear. Thumbs up if it's clear. All right. It means now we are done with this paper. Okay. We are done with this paper. Can we do another map calculation, or we can do GIS now? Can we do another map calculation? I want to do one. Let's do one. Let's do the last one. All right, let's do this one. Okay, this is the last one that we are going to do for map calculation. Then we can do GIS. Let's do this last one now. It's the paper. Okay, we have got the map of Kronstadt. I'm not going to read the background. This is the map that we have. Let's get to the question, guys. I'm not going to read the background now. So we have got these questions. Let's do this one, then we can move on to 3.1.1. The scale of the orthophoto map is dash times larger than the topographical map. What is the answer there? What is the answer there? The theory we have done, or we have done the theory already for paper 1, guys. We have done the theory already. I think we did that. I think it's 2-3 times. The theory for paper 1, we have done it already. So what is the answer? The scale of the orthophoto is dash times larger than the topographical map. What is the answer? What is the answer? It's 5 times. That's correct. It's 5 times. Where do we get these 5 times? Do you know how where these 5 times come from? Let me show you. Let me show you where these 5 times come from. Let me show you where these 5 times come from. We have something like this. This is for our orthophoto divided by, this is for our topographical. I want you to follow this. I want to show you where it comes from, the 5 times. This is how they calculate. This is how we get to the 5 times. 1 over 10,000 divided by 1 over 50,000. Then we'll say 1 over 10,000 multiplied by 50,000 over 1. We divide the zeros, 0, 0, 0. Then we have got 5 times. This is where the 5 times larger comes from. This is the calculation. This is what got us to this, to say it's 5 times larger. This is how you do it. This is where it's come from. Are you following? This is where the 5 times larger comes from. This is where it comes from. If it's clear, thumbs up, then we can continue. The correct answer there is 5 times larger. This is where it's derived from. Okay, it's not just guesswork. This is where it comes from. Okay, let's move on to the next one. Due to the influence of the map scale, the features on the topographical map are dash than the orthophoto map. What will be the correct answer? 3.1.2. Remember, our topographical map is a small scale map. Ne? This is a small scale map. The bigger the number, the smaller the scale. So what will be the number then? Due to the influence of map scale, the features on the topographical map are, what is the correct answer there? It's C. What is the correct answer? 3.1.2. They are small with less detail. Remember, our topographical map is a small scale map. So it shows a larger area, but the features are small with less detail. So the answer there is C. Is C. The answer is what? C. Remember, a topographical map shows a larger area, but the features there are small with less detail because it's a small scale map. If we all understand, just a thumbs up. Thumbs up if you all understand. Then we can move on. The correct answer is C then. All right, don't worry about these two. These two are coming from this we didn't read. It's coming from this. So let's not worry about 3.1.3 and 3.1.4. Let's do 3.1.5. 3.1.5. 3.1.5. These two are coming from this background information, guys. We didn't read it. It's coming from the background information. It's in Junction Town. What do they do? It's gold. That's okay. Okay. You can see here where it's written gold mining, what. So we are not going to do that. Let's do 3.1.5. 3.1.5. Refer to the topographical map. Name the feature found at the coordinates. Name the feature found at the coordinates 27 degrees 39 minutes 26 seconds south, 27 degrees 12 minutes 44 seconds east. This is very interesting. I want to show you how this is done. This is very interesting. All right, let me get the map. Okay, so we are saying from our topographical map, the feature, let's find out first the degrees, these degrees that we have in the minutes. So the feature is found on 27. This is our latitude. So it means going downwards is 36, 37, 38, 39, 40. Then we have at the bottom 41, 27, 41 south. That is our latitude. Then our longitude from here is 27 degrees 10 minutes east. So it's 10, 11, 12, 13, 14. Then we have got 15 there. So our feature is in 2939. Let's find out 2939. So it means 36, 37, 38, 39. So it means our feature is between 39 and 40. Do you agree? It's between 39 and 40 latitude. It's between 39 and 40, which means it's within here. That's where it is, because it's 27 degrees 39 minutes. We are given the seconds, but that's where it is. Then in terms of longitude, we have said that is 27 degrees 12 minutes. So we have got the 27 degrees here. 10, 11, 12, which means our 12 here is here and our 13 is here. So in terms of the longitude, is between 12 and 13. So let's go down now. Let's go down now. So it means our feature is in this grid. Is in this grid. Our feature is in this grid that is at the center. That is where our feature is. Because here, 39 to 40, there, that is your 12 and 13. That is your 12 and 13 in between. So this is the block that we are dealing with. This block here. This is the block that we are dealing with. This one. The one that I have. Okay. This is the block that we are dealing with here. Okay. This is the block that we are dealing with. The one that okay. Can you see? This is the block that we are dealing with in here. Okay. Are we together or someone is lost? Are we together? So we are going to use our seconds so that we convert them into centimeters. We are going to convert our seconds that is already given so that we can be able to find what feature is found in that grid. Okay. So we have said number one, our latitude is 27 degrees 39 minutes. 27 degrees 39 minutes here. So we have said from 27 degrees 36, 37, 38, 39 and 40. So it means it's within this latitude 27 39 minutes and 27 40 minutes. So it's found in between here in terms of latitude. That's what we are saying. 39 minutes and 40 minutes. That's where we have got our the feature that we are talking about. We are saying now this is 39. Let me just draw it like this. This is 39. This is what? 40. So in terms of latitude, our feature is found behind 40 because all this is 39. So we are saying is found between these two latitudes, 2739 and 2740. Remember here is written 2739. So which means anything behind 40 is still 39. So that's why I've drawn these two lines. Then let's look at our longitude, 2712. So 2712 is between 12 and 13. So this is our 12 here from the top. I'm going to draw it going downwards. 13, I'll do the same. So this is what where we are focusing on here. This is the block where our feature is. Do we all understand now? Do we all understand? So we have got these two things. Do you all understand now? So we have got two things. We have got this on the map. the 27 and the 39. We have got the 27 and the 12. So what we are going to do now, we are going to convert our seconds into centimeters. Okay, so how do we go about it? Remember, we once measured from 39 to 40 and we said we have got 3.7. Do you still remember? We measured this grid from our 39 to 40 and we said we have got what? We said we have got 3.7. We said we have got what? 3.7 centimeter. Do you still remember this? So we are going to take our seconds here, which is 26 seconds. We'll say 26 seconds over 60 seconds. Then we multiply by 3.7 centimeters. Are you following? We have taken these 26 seconds on our latitude over 60 seconds. Then we multiplied by the total length of our grid, which is 3.7 centimeters. Are we together? Are we together? Are we together? We want to change our seconds into centimeters so that we know. So we are now saying 26 over 60 multiplied by 3.7, like this. 26 seconds over 60 seconds multiplied by 3.7. Then we are going to get what? This is our answer. We are going to get 1.6. We are going to get what? 1.6 centimeters. So it means now we go now to our grid. Then we measure from here, from the top. From the top, we want 1.6 from the top, which means we are going to measure from here. We are going to measure now from here going downwards. Then we are going to get our 1.6 somewhere here. That's where we are going to get our 1.6. Somewhere, where? Somewhere here. Then we are going to draw our line, which means from here going towards the south, from here up to there, it's 1.6 centimeters. From here up to there, it's 1.6 centimeters. Okay, let's check now our longitude. We have already measured here. We have said that is 3.3. Do you still remember? From here up to there, we have said is 3.3. We have said that is 3.3. So what are we going to do now? We are going to take our seconds in longitude, which is 44 seconds over 60 seconds. Then we multiplied by 3.3 centimeters. That's what we are going to do. 3.3 centimeters. So we are going to take our seconds here. 44 over 60 multiplied by 33. Okay, 44 over 60 multiplied by 3.3. That's what we are going to do. Then what are we going to get here? We are going to get 2.42. That's what we are going to get, 2.42. We can say 2.42, okay? Let's check now. So when we go back now to our map, 2.42, going towards the east from here, 2.42, we can just say 2.4, going towards the east, we are going to get it 2.42, okay, 2.4, somewhere there. We take it down now. What are we going to get now? You can see where they cross now. In the same block where they cross, this is the one that we are talking about, where they cross. This is your 1.6, this is your 2.4. Your 2.4 is from there going towards the east. Then your 1.6 is going downwards. So here where they meet, that's where the landform is, here where they meet. Can you see where I've circled? That's how you will find the landform. That's how where you find the landform. I'm seeing, what feature am I seeing? Can you see here? I'm seeing a reservoir. Can you see here? Let me show. There is a reservoir here. That's what I'm seeing. I'm seeing a reservoir. If it was a little bit down, it was going to give us more of a ruin as well, but I'm seeing more of a reservoir. That's what I'm seeing. That's how you do it. That's how you do it. Thumbs up if you are fine. But if you don't understand at this point, why did you do it on the other? Here, guys. Check here. This. On this point. Okay, sharp. Let's do this now. Calculation. Provide evidence that the orthophoto was taken before 2 o'clock. Provide evidence that the orthophoto was taken before 2 o'clock. Remember, the clear picture is taken either 2 hours before midday or 2 hours after. That's where you get the picture with the higher resolution. The picture is taken either 2 hours before 12 o'clock or after. That's where you get the picture with the highest resolution. That is the clearest picture. So the question is saying now, provide evidence from that orthophoto was taken before, was it before or after? Before 2 o'clock. What evidence is there to show that it was taken before 2 o'clock? What evidence is there to show that the orthophoto was taken before 2 o'clock? I want to show you here, you look at the shadows first. That's the one thing that you look at. Can you see the shadows? Number one, they are shorter. You look at the buildings like, okay, let's look at this one. Can you see? There is the shadow. The shadows are shorter. You can see here, the shadows are shorter. You look at the buildings that you have there, the shadows are shorter. Okay, they are shadows, they are shorter. That's what you can also, they are also lying towards the south. Can you see? Lying towards the south. That is something that you can also use to show that it was taken before 2. That's what you can do. That's what you can do if you want to understand this. Okay. Are we fine? I want us to do the last calculation. The magnetic declination. I want us to do the magnetic declination now. All right, let's do the magnetic declination. Time is moving now. Calculate the magnetic declination for 2025. How do you calculate the magnetic declination? We are using this map of Kronstadt. So how do you calculate the magnetic declination? We are doing the magnetic declination now. So this paper is a 2025 paper. So we are going to use the current year as 2025. But please, if you get a paper tomorrow, you use 2026. So this is a 2025 paper. So we start by saying difference in years. Okay? So the year when this paper was set is 2025. What is the year on our map? Let's check. You use the way that is shown here. The one where your magnetic declination is. Magnetic declination 19 degrees 54 minutes west of true north, 2013. So you use 2013. That's how you calculate your difference in years. This is the year that you use, not this one. You use the year where there is your magnetic declination. Okay? So you say minus 2013. Please, we are using 2025 because this paper was set in 2025. But if you are going to get your paper, you use the current year, which is 2026. Please, don't confuse the two. We use the current year. Are we together? We use the current year. All right. But we are using, this paper was set in 2025. We are calculating one for 2025. That's what is given. So 2025 minus 2013. 25 minus 2013. That is 12 years. So you write your 12 years. Then what is the annual change? Okay. What is the mini annual change? We have got it here. That is mini annual change 3 minutes westward. That is our mini annual change. 3 minutes westward, which means now for us to get the total annual change, we are going to say the difference in years, which is 12 years, write it in full, multiplied by 3 minutes westward. That's how we do it. So we will say 12 years multiplied by 3 minutes westward. What are we going to get? We get 36 minutes W, which is westward. Okay. Then what is our magnetic declination, the current? Now, we are going to take the magnetic declination that was in 2013, according to our map. We take this 19 degrees 54. That's what we are going to do. We take this that is shown on the map for 2013. That is 19 degrees 54. So we are going to say 19 degrees 54 minutes west of true north. Then we add the total change, which is 36 minutes westward. Do you all understand this? Do you all understand this stage? Is this stage clear? Can you read the question? There's someone who's saying, why are we using 25? I want you to read the question. Someone is saying, why are we using 2025? Look at what is written on the paper. Are we together? Thumbs up if we are together. I don't want to confuse you guys. Thumbs up if we are together, sharp. So we are now taking the magnetic declination for this year. That is 2013, which is what? 19 degrees 54 west of true north. Okay, 19 degrees 54 minutes west of true north. This is 19 degrees 54 minutes west of true north plus 36 minutes. We are adding the magnetic declination for the year that is subtracted from, that is 2013, plus our annual change, the total annual change, which is 36 minutes westward. So we add, let's try to add the degrees and the minutes separately. So we will have 19 degrees. Then if we add 54 plus 36, what do we get? 54 plus 36 west of true north. So we have got 19 degrees. If we say 54 plus 36, what is our answer? 54 plus 36. 54 plus 36. What do we have? We got 90. So we have got 19 degrees 90 minutes west of true north. We do not leave it like that. We do not leave it like that because our 1 degree is equivalent to 60 minutes. So we have to change these minutes into seconds. We have to change these minutes into seconds. Okay, because our 1 degree is equivalent to 60 minutes. So we are going to, we can just subtract, guys, to make our life easier. So it means it's going to be more like 19. We are going to take the 60 minutes from the 90, which is more like 90 minus 60 minutes. So we'll have plus 1 degree plus what? The remaining minutes, 30 minutes west of true north. Then we are going to end up with what? 20 degrees 30 minutes west of true north. That is the answer. It's not westward, it's west of true north. Remember, our magnetic declination is west of true north. Our answer for magnetic declination is not westward, it's west of true north. So you should always write it as west of true north. That's how you are supposed to do it, west of true north. Are we together? West of true north. West of true north. Thumbs up. If it's fine, let's go to GIS. I think we are done now. Let's go to GIS. Let's go to GIS. Sharp. Let's go to GIS. GIS, we are going to use the 2025. For GIS, we are going to use the 2025. All right, we are going to use the 2025 for GIS. We are going to use the 2025. 2025 for GIS. GIS. Guys, paper one, I've done it already, guys. I think we had about 3 lives about paper 1. We covered that in depth. We covered paper 1 in depth. We covered everything in depth. All right, let's do GIS. GIS now. All right, let's do GIS. All right, what do we have? Geographical Information Systems, GIS. That's what we are doing now. So the first thing, when you are looking at this, when you are looking, paper 2, we did this, we covered it. Was it yesterday? That's when we did paper 2. Now it's Web Mapwork. We did paper 2 yesterday. So Geographical Information Systems, what do we have here? What comes to your mind from what you are seeing here? Your data layering, isn't it? Your data layering. That's what comes to your mind. Remember, when we look at our map, let me use the one that we have. The map is made up of different layers. Please don't forget to tap the screen. It's made up of different layers. We have got a layer that shows the relief or topography. That is your contour lines. Okay? What else do you have? We also have a layer that shows the land use. That's another layer as well. We also have a layer that shows the infrastructure layer. So we are saying data layering, this is when the different layers are put on top of each other on a map. That's what this is all about. We have got information that shows the infrastructure, information that shows maybe the relief, the vegetation, the drainage. So these are the different layers that makes up a map. So when you're looking at this now, we have got the vegetation layer. Obviously, this is more of your drainage that shows the rivers. This is more of your drainage layer. This is more of your what? Your drainage layer. Okay, so just to give you an idea of what we are talking about. Okay, so what do we have? Refer to block E3 on the topographical map. What is data layering? Let's just go to this. What is data layering? What is data layering? What is data layering? What is data layering? It refers to the layers of information that are placed on top of one another. Layers of information that are placed on top of one another. If you look at this map, there's information about infrastructure, a layer that shows infrastructure, your roads, telecommunication, and so on and so on. There's a layer that shows different land use, where you've got your industries, where you've got your residential areas. There's a layer that shows drainage, where you've got your rivers, and so on and so on. You understand? There's a layer that shows the relief, where you've got your contour lines, that's the topography. So data layering, this is when layers of information are placed on top of one another or on top of each other to create maps. That's what we call data layering. So that's what data layering is all about. Okay. Are we fine with 3.3.1 about data layering? Are we fine? Thumbs up if you are fine with data layering. 3.3.1. Okay, sharp. Then the next question says, name the data layer at B in the sketch above as it is represented on the topographical map. What layer is this one now? What layer is B? The data layer in B as it is represented on the topographical map. What do we have? Non-perennial water, which means it's more of your what? That is a drainage layer. That will be your drainage layer. Drainage layer. That is your 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 drainage layer. Are we following, guys? Are we following? But I've given you a proper definition for data layering. I've given you a proper definition. Didn't I, guys? Data layering. This is when layers of information are placed on top of one another in order to create maps. The layers, different layers are put on top of one another to create maps. I've even explained that when you look at this map, it is made up of different layers. There is a layer that shows drainage. There is a layer that shows the topography, that is part of your contour lines, height on the map. There is a layer that shows the infrastructure, that is your roads, telecoms, the power lines, and so on. There is a layer that shows the different land use. You understand? I just give you a simple and straightforward definition. This is when layers of information is put on top of each other in order to create maps. That's different layers are placed on top of each other. That's data layering. That's what it's all about. Okay, so that's 3.3.1. So are we fine with 3.3.1? The second one, we have said non-perennial water, that is your drainage. That is your drainage layer. That is your drainage layer. Okay, so now it's saying 3.3.3, redraw layer C on the sketch above. In your answer book, apply the data layers A and B. So we are going to apply the data layers what? A and B. What do we have here? We are going to put this here on this. So what are we going to have? We are going to have something like this. Okay. You're going to have something like this. Okay. There, what do we have by the corner? Okay, I've made it bigger. Let me just make it a little bit smaller. I've made it bigger. It's too big. The way I've drawn it is too big. All right. It's too big the way I've drawn it. All right. Okay, we are going to have something like this. Then what do we have on the other hand? I'm going to take this. I'm going to take this. Okay. Then it comes here. Then here it goes like this. Then it goes like that. Then here it's okay, which means here it's gonna be more like, okay, like that. Then what we have here, we have got something like, we have got something that is coming from the other side. Okay, going like this. Then here what we have, we have got something like, okay, going there. Then okay, so now this is what you are supposed to have now. You have put all the data layers. Okay, what we have here as well, I forgot something here. So I've just put this 1 2 3 4 5. That's what I've done. I've just taken this 1 2 3 4 5 and I put it on the same map. That's basically what I've done. So you get your mark for, how many marks are there? 3. You get your marks this, you have shown this, you have shown that, you have also shown the road. That's basically what we have done. So these are the different layers that are shown from here, this one, this, and this. So all these are on one map now, which is your data layering. Is it clear? Thumbs up if it's clear so that we can do the last one. Thumbs up if it's clear. All right, thank you. 3.3.4. The open space indicates buffering is taking place in order to limit urban development. All right, let's go to the map. In where? E3 and E4. E3 and E4. E3 and E4. E3 and refer to the open space now in block E3 and E4. E3 and E4. This is your E3 and E4. These are the two blocks, E3 and E4. E3 and E4. Okay. The open space indicates buffering is taking place in order to limit urban development. Okay. Name two pieces of evidence on the topographical map that suppose the need for buffering. That suppose the needs for buffering. What do we have? That suppose the need for buffering. That is 3.3.4. What do we have here? That suppose the need for buffering. E3 and E4. What do we have? Can you see what we have here? We have got a dam there. Can you see? Which is more of your... Can you see here? For non-perennial water, more of your non-perennial water. What else do we have? That's what you look at now. What else can you have? You also have your sinkholes. Can you see here? That's something that is coming from the map. That is your sinkholes. You can see as well your your sinkholes. We have said sinkholes. We have also looking at the subsiding ground. These are evidence that are on the map. Subsiding ground. These are things that are on the map that you get on the map that supports. Okay. So this is the open space indicates buffering taking place in order to limit urban development. Name 2 pieces of evidence on the topographical map that support the need for buffering. So this is what supports the need for buffering. I think that's all, guys. Some of you are writing tomorrow. Some of you are writing tomorrow, guys. Let me give you a chance to start. Let me give you a chance to start. Some of you are writing tomorrow. You're writing paper 1. So let me give you a chance to start. So what I can do, I can reshare my the paper 1 live. You just send a message to me, then I'll reshare the paper 1 live. Okay, that's what I'll do. Thank you so much, guys. Can you let me give you a chance to start your paper 1? I wish we could have continued, but you have to continue. You have to start your paper 1. So thank you so much, guys. Thank you so much. Thank you so much. So if you just send a message, then I can reshare. I can send it the whole live to you. If you can just send a message on TikTok, then I can just forward the live. I can forward the live. Thank you so much. Thank you so much, guys. Thank you so much, guys. Thank you so much. Thank you so much. Have a blessed evening. Paper 2, we did it yesterday. I think we have done with both paper 1 and paper 2, guys. We have covered everything. Thank you so much, guys. Thank you so much. Have a blessed evening. Before you go, guys, just tap the screen. Before you go, tap the screen, please. Tap the screen. Let's get to 100 before you go. Let's get to 100. That's the only thank you that you can give me. Let's tap it to 100 before you go. Let's get it to 100. It's almost on 50K now. Before you go, let's just tap the screen. Let's tap the screen. Let's tap the screen before you go. Let's get to 100. Let's get to 100. Let's get to 100. Let's get to 100 before you go. Now it's 50K. Let's tap the screen before you go. Let's tap the screen. I'll also share the paper too. Okay, it's fine, no problem. Let's tap the screen. Let's tap the screen before you go. Yeah, for today we are done, guys. I want to give you time to start. But before you go, tap the screen, guys. Tap the screen, tap the screen, tap the screen. Tap the screen before you go. Tap the screen, tap the screen. Tap the screen. I will share just now. I'll share for those ones who have inbox. I'll share. Let's tap the screen. Let's tap the screen before you go. Thank you so much. Thank you so much. Let's get to 100K. Let's get to 100K. Let's tap the screen. We are on almost 60 now. Let's keep on tapping. Keep on tapping. Let's get to 60K. Let's get to 100K. Let's tap the screen before you go. Just tapping the screen. Tapping the screen. You can just tap the screen before you go. Tap the screen, tap the screen, tap the screen. Before you go. You're almost there. Tap the screen before you go. Tap the screen. I really appreciate your tapping, guys. Tap the screen, tap the screen, tap the screen before you go. Let's get to 100K before you leave. Let's get to 100K before we leave. Get to 100K, 100K. We are almost 65 now. Let's tap the screen. Let's tap the screen. Let's tap the screen. I'll send the link, guys. I'll send the link. I'll send the link. Thank you so much for attending. Let's just tap the screen until we get to 100, guys. We are almost on 70K now. We're almost in 70K. Let's tap the screen. For both paper 1 and paper 2, I'll tap the screen. I'll share the link. Let's tap, guys. Let's tap. We're almost on 100. We're almost on 70K now. You want paper 2 tomorrow? Okay, we'll see. I'll communicate. We're almost there, guys. We're on 70K. Let's get to 100. Let's tap the screen. Let's tap the screen. Let's tap before you go. Let's tap before you go. Let's tap before you go. Let's tap the screen. Let's tap the screen. We are on 75. Let's get to 100. We are almost there. We are almost there, guys. Tap the screen. Tap the screen before you go. I'm seeing your messages, guys. I'm seeing your messages. I'm seeing your messages. I'll respond. I'll respond. Let's tap the screen. We are almost on 80K. Let's get to 100. Let's get to 100. Let's tap the screen. Let's tap the screen. Let's tap the screen. Almost 8K. Almost 80K. Almost 8K. Let's get to 100. Let's get to 100K. Paper one, paper one, paper one. Okay, whilst you are tapping the screen, maybe I can say one or two things. Maybe I can say one or two things while we are tapping the screen. Guys, I'm going to share the live for paper one and paper two, what we have done already. So you just send me a message, then I can just forward it like that so that you can have access to it. Okay, both paper one and paper two, I will share. We are on 80 now. Let's tap the screen, guys. We are almost there. Let's get to 100, then we call it a night. I'll be sharing just now. I'll be sharing just now. I will be sharing just now. Just now. Just now. Just now. It's almost 90. Let's get to 100, then we call it a night. Don't forget to tap the screen, guys, before you go. Don't forget to tap the screen. Don't forget to tap the screen. Almost 85. We're left with 15, then we call it a night. Do you have last year's paper for June? Yes, I do. I'll have to check. I do. I'll have to check. I think I have the last year for June. I think I do. But if you have got the prep one and the 2025, I think those ones will help because they're likely to take something from those papers. Okay. We are almost on 90 now. 90. We are left with 10K. 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 Then we call it a night. I'll share just now. I'll share just now. We are left with just 10K. Then we call it a night. Then I'll share. Thank you so much. Thank you so much. Someone is saying I am very fast. I know, guys. I know I'm fast, guys. I know I'm very fast. I'll try to slow down next time. I'll try to slow down next time, guys. Sorry about that. I'm very fast. We are almost there. 94. We are almost on 100K. I just want 100K then we call it a night, guys. We are almost there. 95. Why do you open a board like it's a group on TikTok? I've got a WhatsApp channel, guys. I've got a WhatsApp channel. Just check under channels, just stay simplified FET Geo. Then you have access to the WhatsApp channel. I share some material there. I've got a WhatsApp channel. If you guys just go under WhatsApp channels, then you just type the name Simplified FET Geo. It will come out. Thank you so much, guys. I think we have reached the 100K now that we wanted. We have reached. Okay. So I've got a WhatsApp channel, guys. I've got a WhatsApp channel. Just go under WhatsApp channels. Just type Simplified FET Geo. Then you will have access to the group. I share some material there. Okay, thank you so much. Guys. Let me give you time to start now. Thank you so much. Have a blessed evening.